All right, this video is to go over what a discrete random variable is and how we can use its probability distribution to calculate probabilities for it. So, a couple of things we talked about in class is number one, what is a discrete random variable and what does its probability distribution look like? And so, when we do that, what it's going to be is that a discrete random variable. Now, it is spelled differently than discrete in an English class. So, discrete random variable, and it is different from an algebra variable. And the reason why is because this basically is a variable that takes on a fixed set of values that have gaps between them. Okay, so it's going to take on one of a fixed number of values, and these values must have gaps in between them. All right. So when we talk about its probability distribution, typically the probability distribution you can kind of see one down below in the check your understanding. But what it is, it's going to be a table that's typically comprised of two rows. In the first row, it's going to have our random variable. We'll call it X, for instance. And then it's going to have the entries or the possible outcomes for X. Right? And it could have any number of entries. It is a fixed number of entries, but it could really have any number of entries. In the second row, then, what we will have is we are going to have the probability of each of those individual values. So let me space these out a little bit more. Here we go. And then again, like I'm saying, what we would have is we would have the probabilities that correspond to those possible outcomes. And they will line up 1-to-1 with each possible outcome. So that's what a probability distribution would look like. So you can kind of see one down here below for the check your understanding. Here's our probability distribution. Now, along with that, we need to know that there are two things that make something a valid probability distribution. So valid probability distribution, okay. In a valid probability distribution, there's, again, two criteria, basically. Number one is that the probabilities, let's put something around it so we can tell that it's supposed to be like a list. The probabilities add to 1 or 100%, depending on how they're displayed. So if they're decimals, they need to add up to 1. If they're represented with percentages, they need to add up to 100%. And number two, the probabilities are all between 0 and 1 inclusive, right? Between 0 and 1 inclusive. And so that's what makes it a valid probability distribution. So we're going to use this fact too here, this first one, in our check our understanding in just a moment. Now, the other thing we have to be able to do is we have to be able to draw histograms of them. So we want to be able to draw histograms. Let's make this so I can read that again. There we go. And what I'm going to do is I'm going to shrink the size so that I have room in here. I'm going to make this all a little bit smaller. So there we go. Well, maybe a lot smaller, actually. And here we go. We'll go there. All right. So I can bring this over here because I've got an image of a histogram for a random variable I want to put in here. And here we go. We'll have to resize this thing because it is not going to fit there. But we also, the probability distributions, I said normally are displayed as a table. Well, we can actually display a probability distribution also as a histogram. And so in this case here, if you notice, it has it centered at 1, 2, 3, 4. So it's combining, I'm saying that the outcomes of 2 and 3, but not including 4, has a relative frequency or probability of 35% or 0.35. All right. We're going to come back and add to this in a later video, and that's how to find the mean of a probability distribution for a discrete random variable. But for now, let's see how I could answer some questions. with Check Your Understanding. So, Home Alone is a series of American Christmas family comedy films created by John Hughes. There are 5 Home Alone movies. Below is a probability distribution of the number of Home Alone movies watched by a very large sample of high school students. Write the event the student has 3 Home Alone or has seen 3 Home Alone movies using probability notation. Then find this probability. So, what it means by probability notation is we're going to use like we see down here in part B. So we're going to allow basically our random variable here to be x. That's indicated here in part B. Sometimes you might need to name it. So I might come up here, for instance, just say, well, we've got this here, and we're going to call this thing x. I'm going to make it a little bit bigger again. There we go. So we're going to call this thing, and for random variables, we always use capital letters. So we're going to call this our random variable x, which then is going to make the probability down here. Our probability is going to be the probability of x, right? And so they're lining up. So in other words, it's telling me if I was to randomly select a student from whatever class this came from, there is a 0.15 probability or 15% chance that that student has never seen any Home Alone movies. So we're going to write this event using probability notation. And so again, what that means is I'm going to use this notation of P, let's see here, probability, come on, we'll get it. There we go, the probability that X, and now it says has seen. So this means seen exactly 3, so we're going to say equals 3. And now the idea here is if I go to my table, normally I should be able to see from my probability distribution as a table what the probability of have a student having seen 3 Home Alone movies is. But we notice here that, yeah, that's not the case. I've got a question mark for 3. So then it asks us also, then find this probability. Now above I had said to be a valid probability distribution, all the probabilities have to add up to be 1, or if they're expressed as percentages, 100%. Well, these are expressed as a decimal, and I'm missing one of the 6 probabilities here. So since I know they have to add up to 1, I can use some math here and figure out, well, what is the probability for x being 3 need to be so that the sum of all of these probabilities ends up being 1. So what I'm going to do is I'm going to take 1 minus, and I'm going to add up the ones that I do know. So I'm going to have the 0.15 plus the 0.42 plus the 0.32 plus the 0.02 for 4 plus the 0.01 for 5. And when I do that and I add all of those together, it looks like I have a stray parenthesis in here, so let me take that out. When I add all of these together, what I get is that I end up with 0.92. So I'm going to have 1 minus 0.92, which means that my probability for seeing a student having seen exactly 3 movies is 0.08. Moving on to part B, explain in words what the probability that x is greater than or equal to 3 means, and what is this probability. What this means here is, again, X is talking about the number of Home Alone films the randomly chosen student has seen. And since it says greater than or equal to 3, we're talking at least 3 or more. So that's how I'm going to translate this. So the probability, because again, we're talking probability, that's what that P means in the front. The probability that a randomly selected student. Now, this was not from my classroom. This is data that was given on this activity. Selected student has seen at least 3 Home Alone movies or films. There we go. The probability that a randomly selected student has seen at least 3 Home Alone movies or films. Then it asks us to, well, what is this probability? So I'm going to go ahead and complete my notation. Always use notation when you're finding a probability because it helps somebody that comes along and looks at your stuff identify what it is that you were doing. All right, so let's see, I need to do the greater than or equal sign. I'm going to go in here. I believe there's one in here. Yep, sure enough. My little math tools there. So greater than or equal to 3. Let's take italics off. There we go. And so now it says greater than or equal to 3. Well, I know what 3 is from part A, so I know it was 0.08 plus. Now, what other values were greater than 3? Well, 4 and then 5. And 4 had a probability of 0.02. And having seen all 5 Home Alone films, had a probability of 0.01. We add all these together and we get a probability of 0.11. All right. So now the last part is make a histogram of the probability distribution and describe its shape. Now, because we're dealing with a discrete, there's different ways we can do this. But since we're dealing with a discrete random variable, I think the easiest way to do this is to center our bars of our histogram above the value so we can tell that what value it's representing. But like for any histogram, we need 2 axes. So let's see here. I'm going to see, can I move this out of the way? There we go. We'll move that over here as well. So I'm going to make sure I'm doing it in blue because the whole thing's been in blue. I need 2 axes. I need one horizontal axis and I need one vertical axis. And in this case, my horizontal axis rather, is going to have a scale starting at 0 because that's our first possible value. Then I'll go 1, 2, that looks to be about evenly spaced. Maybe go back one. There we go. 3, 4, and 5. And I think I need another space there in front of the 3. There we go. Those look pretty evenly spaced. And so this is representing my values of X. And in this case, X was number of Home Alone movies. So number of Home Alone movies seen. And that's our random variable. So sometimes we just put our random variable X in there. It's the number of Home Alone movies seen. All right. Now, along my vertical axis, I'm also going to have a scale. If we go back and look, our greatest probability here is 0.42. So we could probably get away with putting a 0.50 on there. So I'm going to come in, I'm going to put in a scale here. And I'm going to start at 0 because that really is where we should start. Always start your scale, your vertical scales at 0. Don't ever use a little break in your vertical axes. I'll say 0.20, 0.30, 0.40. And then I'm going to put this along the vertical axis over there. So I'm going to go ahead and I've got some tools here. It allows me to rotate it. And I'm going to put this, oh, look at that. It's way too big for my axis that I have in mind. So I'm going to shrink these down a little bit. Let's take these down to like a size 11. And that still doesn't fit. So what that means is I'm going to have to go back and take out some of my spaces. And you know what? Honestly, I don't need all of them. So that's what I'm going to do. I'm going to take out some of them. I'm going to take out the odd ones. All right. I'm going to take out the odd ones. And then I'll put some lines on it so that we can see where they're at in between them, so that any reader coming along should be able to identify what the lines represent in between the values. So we'll do that momentarily by hand. So I'm going to space these out a little bit more. There we go. All right, so now I just need to draw my bars for my histogram. So I'm going to come in, I've got a little rectangle tool here. And so for 0 films being seen, it was 0.15. So let's go ahead and put those marks in there for the odd values. All right. I'm going to put these marks in here for the odd values now. And so we're going to call that 0.10. We'll call this right here 0.3 or 30%. And then we will let's put a mark up here for 0.5. So that will be 0.5. And so anybody coming along should be able to identify that that's what those values represent. Now I'm going to go back to my rectangle tool. And here above 0, we had 0.15. So I'm going to come up to, and my tool is in my way. So that's 0.10. So I need to come up to about halfway between 0.10 and, so there we go. We're just going to stretch out our rectangle right there. I'm going to bring it up just a bit. and center it over 0. And so there's my rectangle for 0. All right, then I come back and I'm going to put in a rectangle for 1. That one went all the way up to 0.42. So I'm going to draw another rectangle now. It needs to start down here in about the same place. It needs to center itself. Ooh, I think my spacing's off a little bit, so I'll fix that in a minute. But 0.42, because your rectangle should be about the same width, ideally. All right, so we're going to call that 0.42, and it looks like it's way too wide. But what I'm going to do is I'm going to move it over here, and I think what I could do, what I might be able to do, is just stretch the one out from 0. So let's do that. Let's see if I can get it to stop switching between them. There we go. We can stretch that one out for 0. All right. Now they look like they're a little bit closer to the same width. So we're going to go back to our rectangle tool now. And for 2, we have a probability of 0.32. So again, we're going to come back down here and start at about the same place. 0.3 is right there at that line. So we'll say that that's going to be 0.32 for us. I'll just bump it up a bit and over. There we go. So we've got that rectangle there. Then for 3, we calculated that one ourselves. That's 0.08. So that one's not going to come up very far, but we are going to be able to see it. It'll be like right about, I don't know, it should be close to 0.10. So maybe a little bit taller than that. Let's come back in. We'll make it just a smidge taller. And we're going to bump it down a little bit so it's on the axis there. There we go. I like that. Now we need to do 4 and 5. So 4 is 0.02. So that one's going to be pretty small, actually, 0.02. But I need to leave enough room in there so I can show what 0.01 should look like. All right, so I'm going to shrink that down. Let's see, will it let me shrink it any further? That might be the smallest I can make that. Well, let's go ahead and just make another one in here. All right, so we're going to make one for 5. It's got to be like half that size. And it's going to be like half that size. And I'm going to move it here in just a second because it's sitting below my axis. If I can let it, if it'll let me grab just those values there, or the rectangle. There we go. And so here's a sample histogram for the Home Alone movies. And so that's how we would build a histogram for these things. I'm going to put some marks in there. That's bothering me that they don't have marks. There we go. Now it also says describe its shape. So remember, our shapes that we're going to look at are symmetric, right skewed or skewed right, or skewed left. Symmetric means that my peak is like roughly in the middle, and then the sides are roughly the same distance going out in either direction. But if that's not the case, I'm going to look for, well, which side is being stretched out the furthest? And that's the way it's going to be skewed. So if it's not symmetric, we're going to call it skewed. We just need to know which way it's skewed. So looking at this one, it appears to be stretched out further to the right. So I'm going to call this one its shape. My description of its shape is going to be skewed right. And that should be enough to complete your practice for tonight. And your practice was going to be the problems I handed out to you labeled practice probability distributions, right? Discrete probability distributions. And really, it's just going to ask you questions like A and B for a given scenario. But know that on your test, you may be asked to construct a histogram. And that's it for this video.